Hello students, welcome you all for the 6th class of laws of motion. What did we do in the previous class? In the previous class we have solved some numericals regarding linear momentum under the second law of motion. That is P is equals to m into B and F is equals to m into A. So in today's class let us discuss about the next concept, that is Newton's third law of motion. Already we have studied what we mean by Newton's first law of motion. Before that we have studied what are contact and non-contact forces. Then we studied Newton's first law of motion. Then we studied what we mean by linear momentum. Then we studied the continuation part of that is Newton's second law of motion. We solved the numericals and you also have submitted me the homeworks. So in today's class, let us discuss about what you mean by Newton's third law of motion. You might have heard this. When compared to the two laws, you will feel very much comfort with Newton's third law of motion. It's easy to by hand. It's that by handling is very easy here. But when you understand, all the Newton laws are very much easy. Now first let us recall what are the things we studied in Newton's first law and Newton's second law. Newton's first law, to bring a change in a state of rest or in a state of motion of an object, a force is needed. Obviously right. What did we study? According to Newton's first law, when there is a book on it kept on a table. Okay? When there is a book kept on a table, to bring a change of this, to bring a change of an object, what is needed? That is, to bring a change in the state of rest. To bring the change in a state of rest, what is needed? A force is needed. Right? For example, think a ball was keep on moving. It was in motion. Think that the ball was in motion. To make that is in the state of motion. If it is in the state of motion, to bring to the state of rest, what actually is needed? Again, we need what? Force is needed. This is what we studied according to Newton's first law. That is, we have two types: inertia of rest, inertia of motion. Even Newton's first law of motion is called as law of inertia. Right? According to Newton's first law of motion, if a particle is at rest, continues to be in a state of rest. If a particle is in a motion, it continues to be in a state of motion unless an external unbalanced force acts upon it. Look, I am telling the definition. Have I by-handed? No. I have understood it. Understand? So this is what we studied from Newton's first law. What did we study from Newton's first law? If the object is at rest, if you want to make it in motion, force is needed. If a body is in motion, if it wants to come to rest, again force is needed. Totally force is needed to bring rest to motion or motion to rest. This is what we studied in Newton's first law of motion. Now what did we study in Newton's second law of motion? First, let me write a definition about a mathematical expression. That is, force is equals to mass into acceleration. This is what we derived out of Newton's second law of motion. So Newton's second law of motion, magnitude of acceleration describes A is acceleration, F is force. How force is related? Force is related directly proportional to mass and force is directly proportional to acceleration. Means with increase in magnitude, there is increase in its acceleration. Magnitude of acceleration produced by the force when applied on an object. When you apply a force on an object, it causes the magnitude. Magnitude is quantity of acceleration. If more the force, more the acceleration. Less the force, less the acceleration. This is what we studied from what? Newton's second law of motion. I have taken case 1, case 2. That explained you that for what it is, force, both mass and acceleration need to be changed. If you keep mass constant, change acceleration, then also what? Force changes. If you keep acceleration same, changes the mass, again force changes. So force is dependent on both mass and acceleration. This is what we studied in Newton's second law. Again, in Newton's second law, we came to know force is what? Must and should. Newton's first law also what? Force is must. To change in acceleration here, force is needed. Here, to change the state of rest or state of motion, again, what is needed? Force is needed. This is what we studied in the case of Newton's first law of motion and Newton's second law of motion. Now, observe carefully. These two laws do not explain how does the force act on the body. You understand? These two laws are telling you that force is needed. But they are not telling you that in these two laws we don't know how does the force act actually. Where does it act? It acts upwards, downwards, sidewards, rightwards, no. So if you want to know, these two laws do not explain how does the force acts on the body. How the force is acting, we are not able to see in these two laws. So to know that how exactly the force acts on a body, we need to understand what we mean by Newton's third law of motion. That is Newton's third law of motion. So what is the definition of Newton's third law of motion? So we will see now. According to, we have to define it carefully. According to Newton's third law of motion. According to Newton's third law of motion, for every action, there is an equal and opposite reaction. This is what the statement of Newton's third law of motion. What is the statement of Newton's third law of motion? According to Newton's third law of motion, for every action, there is an equal, this word is very important, equal and opposite reaction. See, definition I have told you, but when I explain you the example, you will correctly understand what exactly I am explaining. Let us see one example. Think that, again a simple example of table and book. Let us say, this is a table. On a table, think that a book is being lying. Right? A book is being lying. See, when you apply a force on a book and take you from there, that comes under which law? Newton's first law of motion. Now, according to Newton's first law, how can we explain this? According to Newton's first law, this is an inertia of rest. It is in the state of inertia of rest. What? Book. When you apply a force, there causes acceleration. That when you take a book and moves, then what? It comes as an acceleration. So how much force you give, that much acceleration. How force is good, book goes and falls there. Understand? That comes under Newton's second law of motion. If you want to explain this example in Newton's third law of motion way, how does it? That is, what is Newton's third law of motion? According to Newton's third law of motion, for every action there is an equal and opposite reaction. Here what action and reaction is happening? That is what we need to understand. Now book is lying on a table, right? For example, think that on your hand you hold some weight, some 5 kg of weight. When you are holding it, what do you feel? You need to apply a force on it to make it to withstand. If you are not applying a force, what happens? It falls down. You are understanding it. The same thing here, book is being applying a force downwards. The weight of the book is acting where? The weight of the book. The weight of the book is acting vertically downwards. Is acting vertically downwards. You are understanding? How does the book is been acting? The weight of the book is acting vertically downwards. So this is called as action. This is called what? Action. Understand? So for every action, we hear this. Now book is applied, no, that is an action. So according to Newton's third law, for every action what? There is an equal and opposite reaction. Equal and opposite. Now which is being applied? Equal and opposite. That is table. Now table can withstand the book, right? How can a table withstand? Book it is withstanding. For example, I got a huge rock and kept on a table. What happens? Table broke. Means for that action there was no reaction. It was not able to give a reaction force. But here table can withstand the book. Means there is table. What it is? The weight of the book is acting vertically downwards. In turn, table is also withstanding the force. Withstanding the force vertically upwards. What it is? Vertically upwards. Vertically upwards. This is called as reaction. What it is? Reaction. Understand? See, this is acting downwards. So in turn, even table is acting its upwards force. So this is called action. This is called reaction. Table's weight is acting. The book's weight is acting downwards. In turn, table also is applying some force on the book. That is acting upwards. So this is called action. This is called reaction. This simple example is enough to understand what you mean by Newton's law. Now, there is an equal and opposite. See, for example, book is applying 5 Newton of force on table. Table also in turn acts how much? 5 Newton only. So these both are what? Equal. There is an equal and opposite. Why it is opposite? It is acting downwards. It is acting upwards. So give a name. For example, for a book, it is AB. This is DA. It is acting opposite now. So how can we write? Force AB is equals to minus of force BA. I can write like that. What means force AB is the force of book acting vertically downwards. In turn, it is opposite. Minus tells me what? It is acting in opposite direction of the same force, that is BA. Just I am giving the names AB and BA. Understand? So remember, this is what the example of what you mean by Newton's third law of motion. True for every action, there is an equal and opposite reaction. When you throw a ball to a wall, action is on the wall. Again, reaction by the wall to you. Wall will act on ball. Understand? That is action and reaction. And one more thing you need to understand that. One note I will explain you now by giving some examples. Then you will understand it better. Now we will see one of the important notes about Newton's third law of motion. Then we have a set of examples, and I will do 2 questions for you there. So that makes you to understand Newton's third law of motion better. After knowing what is the definition of Newton's third law, that is action and reaction. For every action there is an equal and opposite reaction. Let us see now one important note. That is, action and reaction never act on the same body. There is an action and reaction. For every action there is an equal and opposite reaction. You just observe just now. That is by taking an example of book lying on a table. Then table is having an action on table. A book is having an action on table. Where table is having a reaction on book. So action is happening by book on table. Reaction is happening by table on the book. Therefore, action and reaction is not acting on the same body. Did you understand? But they always act simultaneously on 2 different bodies. It will be happening simultaneously. Then only it can withstand. Understand? So let us see some of the very important examples of this action and reaction. And these are the examples of Newton's third law of motion also. Understand? What is the first one? The same example I have taken to make you to understand. A book on the table. A book on a table. Here, what is the book? Book is lying. So action force is on what? Table. Book is applying an action force on a table. Now what is table doing? Table is even applying a reaction force on the book. Now action and reaction never act on the same body. Here action and reaction is acting on the same body? No. Action is acting on a table, reaction is acting on a book. This you should keep in mind. Very important in Newton's third law is only this. That is, action and reaction never act on the same body. Understand? So what is the second example? This you might have felt. Motion of a boat moving away from the shore. How does a boat moves? What does a boatman does? He takes his oar to do like this, right? So he is applying a action on water. So water in turn gives a reaction on boat. That is, it is moving forward. Look here. This is an action. This is an action force. Action force is applying on water. Reaction force is being applied on boat. That is, it is moving forward. So action and reaction is acting here on two different bodies. Right? So motion of the boat is also an example of which one? Newton's third law of motion. It's very easy. And firing a bullet from a gun. When you take a gun and fire a bullet, here action force is bullet. Reaction force is bullet on the recoillation of the gun. This is the reaction force. Even gun, it comes behind. When you fire a gun, you might have played this crackers or not. When you are striking it, it's an action force. So the recoiling what you are getting is a reaction force. Understand? See, this is most very important, and that usually in some of the examinations they will ask. When you go write your government jobs, competitive exams, rocket motion. Always remember the motion of the rocket. What is the principle behind the rockets? What is the principle behind the rocket? Is always Newton's third law of motion. Remember, it's very important. So, rocket works on the principle of what? Rocket's motion is on the Newton's third law of motion. You might have seen in a television, TV, how the rocket launches. When a rocket is launching, you might have seen the gases, number of gases which releases, as it not. So, the number of gases which are releasing is a force of action. There is a force of action happening on the gases. In turn, there is a force of reaction. So that same reaction is force on a rocket, is the reaction force that makes the rockets to move. So very simple. Understand? Look at here. This is called as a nozzle part. Where the gases comes out is a nozzle part. So when the gases are coming out, that is an action force. So now action force is on what? Action and reaction doesn't act on the same body. Action is happening on gases. Reaction is happening on rocket. Understand? Force of action on gases, force of reaction on rocket. Very simple. Understand this? In your textbook they have given. When you are moving also, when you are walking, you are applying a action force on the earth. In turn, earth is also applying a reaction force on you. That is the reason you are moving forward. Understand? So for example, can you walk on a sponge surface? You cannot walk on more on a sponge surface. Why? The reaction force is very less. Understand? So these, and along with this I have taken only 4 examples. In your textbook they have given a few more. Please go through it. I hope you have understood the Newton's third law of motion. Very simple. For every action there is an equal and opposite reaction. So now we came to know in Newton's first law, Newton's second law, we know only we are applying a force. But where we are applying, how we are applying, that we understood in the case of Newton's third law of motion. That is action force, reaction force. There will be how much pair of forces it will be there. One is called as an action force, the other one is called as a reaction force. Here it is acting downwards and upwards. Here it is acting sideways. Wherever you take upwards, downwards or sideways, it will be there. Here, if you push a boat this side, boat moves in the opposite direction. You are acting an action on left third, boat is moving on. If boat should move in a reverse step, your action should be opposite. Always remember, action and opposite. Action and reaction should be opposite to each other, but the force will be equal amount of force. That is the reason we tell for every action and reaction, for every action there is an equal and opposite reaction. Understand? See here also, action is acting downwards, reaction is acting upwards. They will be always opposite to each other. So this is, I hope you have understood what you mean by Newton's third law of motion. Now we will see 2 important numericals which will be asked, very simple numerical in the case of Newton's third law of motion and why comes space. Now we have our 2 problems. Very simple it is. If you understood the about Newton's third law, that is action, reaction, and of 2 different bodies, easily we can solve this problem. Listen. A boy pushes a ball with a force of 10 newtons. Consider this is the ball. A boy is keep on pushing this. A boy pushes a ball with a force of 10 Newton. What is this force? 10 Newton. Towards east, right? What is this according to map? North, south, east, west. So it's pushing towards east. What force is exerted by the wall on the ball? Now this is action. What he is pushing the wall is action. What wall is putting a force on him is the reaction. So what is Newton's law of resistance? For every action, there is equal and opposite reaction. Equal means if he is applying 10 Newton towards east, what is the reaction? Reaction. And what force is exerted by the wall on the ball? What force? A force of 10 Newton towards west. This is the answer. That's all. See, opposite direction gives you west. East, west. If you are applying action towards east, opposite force, reaction is towards west. But equal, the force whatever you are applying will be equal in the case of reaction also. Understand? So this is the answer. The answer is force of 10 Newton towards west is equal. Very simple. Common sense it is. Next one. We have a string which is being tied and a weight has been holding it. This is the rigid support. What is the question? A block of weight 15 Newton. There is a weight of 15 Newton is being hanging from a rigid support by a string. This is called string. Already in this chapter itself, when we are studying contact non-contact forces, we have seen. Always in a string it will be which force? It is tension force. Remember, in a spring always there will be a tension force. What force is exerted by the block on the string? What is the force exerted by the block on the string? So it is your answer. The force is how much? Okay. Force of about block on the string. No, force of 15 Newton downwards. It is how much? Downwards. Because weight is acting downwards. It is making string back downwards. So your answer is force of 15 Newton downwards. String on the block. What is making the string to hold the block? Because it is force of 15 Newton upwards. 15 Newton upwards. So these are the very simple concepts. I hope you have understood all the 3 Newtons, 3 losses. First law, second law, third. Understand? So in the next class we will go for gravitation. What do you mean by gravitation? I want you to complete all the exercise questions.